Okay, we're alive. Okay, we're live, I mean. We're alive, too. Okay, solving systems of equations using elimination. We've already talked about this. You guys already know how to do this. There's just one last type of an example that I didn't show you on Friday, and I want to show you this. I know you guys could figure it out without my showing it to you, but I'm going to show it to you anyway. Again, we use the same process that we did before. We look at the coefficients in front of the x, in front of the x's, and the coefficients in front of the y's, and our goal is to have the coefficients in front of the x's or the y's, one of the two, to be the same number, only they're opposites. One's positive, one's negative, right? So I'm looking at, first the x's, I got 2, negative 3. Well, those aren't the same. So I'll go over here. We'll probably have to, oh wait, 5 and negative 4. Those aren't the same. Yes, question.
So we multiply like both of the equations by something now?
Yes!
Okay.
Exactly. You have to multiply both equations by something so that you get them to be the same, only opposites, right? So what would you choose? I notice here it doesn't, there's two ways. I mean, you could choose things to multiply to get rid of the x's, or you could choose things to multiply to get rid of the y's. Doesn't matter. The only thing is, I just happen to notice these happen to be slightly larger numbers here, so I'd rather multiply them by smaller numbers than bigger numbers, right? And I notice here, what would I have to turn the coefficient into? In other words, what's the least common multiple? Remember that? Least common multiple between 5 and 4. 20, right? So that means to turn 4 into 20, I'd have to multiply the bottom by 5, and I'd have to multiply the top by 4. Well, I guess I could do that, but those are big numbers. I look over here and I see, oh, 2 and 3.
6.
That would be 6. That would be a smaller number, right? So I could actually, and so what could I multiply these by then? I got to turn this into a 6x. So I'd multiply it by 3. So I'm gonna here, I'll use a different color for this. I'm gonna multiply the top one by 3, right? And that'll give me 6x. And the bottom one,
By 2.
I will use a different color. I will multiply the bottom one by 2. Exactly. Okay. So that's gonna give me 6x plus 15y equals, so 3 times 6 is 18, carry the 1. 3 times 2 is 6, 7. 78. Did I do that right? Does that sound right to you guys?
Yeah, that's right.
All right, now negative 6x, right? 2 times negative 3 is negative 6x minus 2 times 4 is 8y, okay, equals, now 2 times negative 25 is negative 50. Those are just easier for me to multiply. This is not a good marker. Now we'll go back to the brown. All right, so now we're ready. Is everybody clear on how we just did that?
Yes.
Makes sense, right? You're just looking, it's sort of like finding a common denominator, right? The common denominator, if you had a 2 in the denominator and a negative 3, or a 3 in the denominator, you would have to figure out, well, what's my least common denominator, which would be 6, right? Or here would be 20. It's the same idea. That's what lowest common multiple is. So, okay. So here we go. So we are going to cross out, eliminate. And then 15 minus 8. Oh, I used to know that. 7, that's it. 7y is equal to 28. Oh, wow, look at that. That's so awesome. Look at that. Now, let me ask you a question. In real life, do you think they're all going to come out as whole numbers?
No.
No, they're not.
I was like, that's weird, because in the purpose of this, that we can figure it out when it's not a whole number, like of elimination substitution, because you can figure this out by graphing it.
Well, I'm going to explain, after I finish this, I'm going to explain why elimination is really useful. Because especially with the hard ones. I mean, if I had to do a really hard one that's going to have fractions, I would definitely choose elimination.
Well, I know, I'm just saying, like, these are kind
Hands
of
down.
weird, because that's like one of the main reasons why you use elimination or substitution.
Right, because
And
then
so
it wouldn't
why
cross.
make it full numbers?
Exactly. Good point. That's a really good point. Exactly. All right. So what is that? 4, right? So that was easy. Okay, so now that was all we had to do that was different. Now we go back to the original problems, right? Without the 2 and the 3 multiply. And we're going to substitute the 4 into either one of them.
Top one.
Top one? Okay. So 2x plus 5 times 4 equals 26. So 2x plus 20 equals 26.
Subtract 20.
Subtract 20.
2x equals 6. Divide by 2. Divide by 2. X equals
3,
x
4.
equals 3.
Wow, you guys are fast. Okay, divide by 2. Divide by 2. X is equal to 3.
3,
So there we go. So we could say 3, comma 4. Or we could just say x is equal to 3 and y equals 4. Right? It's pretty straightforward, right? It's not that hard, right? Now, so like I was saying, there will be times when you will get fractions, right, as your answers. Now, in substitution, like if I use substitution, the substitution method, sometimes what I have to substitute into it is a horrendous fraction. Well, I wouldn't want to do that, right? If I didn't have to. I could, but I wouldn't want to if I didn't have to. So I could use elimination. So I'm going to make one up, and I'm going to make one off the top of my head, and it's probably not going to work except for fractions, right? And I've got 4 minutes. Okay, so can I race? Are you guys done? All right. So, I'm going to make it, let's see here. I don't think I'm going to try to make it slight. Well, I guess we'll do it like that. Let's just say 2x plus 5y equals 11 and negative 4x minus 3y equals 1. Okay, my guess, I don't know, I'm just making it up. And there's a chance it'll come out so in whole numbers, but the likelihood is low, right? So we'll just see. What would you do?
Well, for you to change it.
Top 1 by 2.
Yeah, if I multiplied the top one by 2, I'd have positive 4x here and negative 4x there. That'd be perfect. So let's do that. So we'll multiply this one by 2. So we've got 4x plus plus 10y equals 22, right? And then here we got minus 4x minus 3y equals 1. All right, now we're going to add them together. Now look at this. Now look at this. So we are eliminating. Now let me just clarify. Which one are we eliminating? The x's or the y's? The x's, right? Right? And this one. And this one.
Gary, if you had made a negative one, it would come out even.
It will come out even?
It would have if you had.
Oh, really? Oh, good. Phew. I'm glad I didn't. Okay. So we have. So we have 7y, right? Oh yeah, you're right. Okay. Equals 23, right?
Oh, yeah, because you're adding.
Okay. So now I'm going to divide by 7. Divide by 7. So y is 23 sevenths. And I could write that as a mixed number, but you know what? Mixed numbers aren't going to be that useful. Because if I had to substitute this in, it would be easier to have it as an improper fraction, right? Does that make sense? So I'd rather not turn it into a mixed number right now. All right. Now, I have to substitute this into one of these equations. Does that sound like fun?
No.
Maybe. We could, and it would be sort of fun, maybe. Kind of in a sick kind of a way, right? There would, right? So that's one way. I could substitute that in. Or this is like amazing. Landon, you got to hear this. This is amazing. This is an awesome, awesome trick. Instead of substituting this in to find this other horrendous fraction that's going to be x, I could go back to my original problems. And I could do this. Watch this. I'm going to erase what I just did.
Well, then you have to do it again.
And I'm going to make the y's disappear. I'm going to eliminate the y's now. And so I won't have to deal with fractions, right? I won't have to deal with fractions at all. Watch this. This is so cool. So we found out that y is that, right? I'm not even going to substitute that in. I'm just going to forget about it. But now, what would I have to multiply these by? What's my least common multiple? 15, right? So they're opposite signs. That's good. So I'm going to multiply the top one by what?
3.
By 3.
By 3. And the bottom one, try a different blue, by 5, right? Am I right?
Yeah.
And then it'll be 15? Okay, so the top one, we have 6x plus 15y equals 33, okay? And the bottom one, we have negative 20, right? X, and then minus 15y is equal to 5, right? Okay, now look what we got. Now, those cross out, right? Right? So now I just have, what is that, negative 14x, am I right? Okay, equals, because I'm adding this, equals 38, right? Okay, all I have to do to find my x is I divide by negative 14, and x is equal to negative 38 fourteenths, which actually I could divide both by 2. That would be 19, right? Oh, negative 19 over 7, right? So look at that. So that was so much easier than substituting 23/7 into one of those problems. You see what I'm saying? See the difference? And that's really cool. Now I'm not going to give you those likely on a test or anything like that. But that's basically it. And the homework tonight is 4 problems like these. They probably will have whole numbers. And then just a little bit of review. You guys remember how to graph something in standard form, finding the x and y intercepts? The x-intercept, you make y equal to 0. The y-intercept, you make x equal to 0. You remember how to rewrite something that's in that's in standard form with the x and y's on the same side. Remember how to manipulate it so that it's now into y equals? Remember how to do that? You just did that like last week on your homework. You subtracted the x's and then divided by the number in front of the y's and you got y equals, right? Remember that? Okay. So that's another one. And then I asked you to graph it using slope-intercept for y equals mx plus b format, right? But I didn't give it to you in that. And then also using the point-slope form to write an equation and then graph it. Remember how to graph point-slope? You have a point, you plot the point, and then you use your slope from that point. Rise over run, right? And then the last one is finding the slope of a line that passes through 2 points. Remember that slope formula? M is equal to the change in y over the change in x, like y2 minus y1 over x2 minus x1. Remember all that? You guys will have no trouble with this one. My dear, so this is due tomorrow. We're probably going to do, I'll just warn you guys, we're probably going to do mostly my thing and a lot less Saxon. I'm going to do Saxon maybe more like once a week. And then, because I just want to keep you guys current on all that other stuff that I don't like to teach. But,
Oh no, that was Serena, in the tiny plant cell, it looks like sweat. Really? In the tiny plant cell over there, it looks like sweat. Where? Over there. It's so cute. Oh my goodness. Oh my god. Whoa.
so Nathan, bring your homework tomorrow.
Yeah.
Last week. Last week. Oh wait, I forgot to turn this off.